Welcome to the demonstration of our CPU memory placement simulation using the best fit algorithm. Today, we'll run a simulation with the specific memory and process values and demonstrate how the best fit algorithm operates. We will start by inputting our values into the simulation. Let's try to put 600 kilobytes into the memory size with 5 processes. Process 1 with 100 kilobytes with the time unit of 3, 250, 7, 3, 3000. Let's try to put 3000 milliseconds for the time for compaction and 4000 for the time for coalescing whole milliseconds. Let's try to run the simulation. The best fit algorithm aims to minimize the wasted space by placing the process into the smallest suitable hole. For example, in the given, which is we have 69, 97, 100, 234, and 250. The program will choose process 3 with the size of 69. The compaction time involves moving processes in memory to create a larger contiguous free space. You'll see that here, if we finish process 5, it creates a hole here, and now compaction will move the processes towards the first index. As you can see here, there is now a bigger space. The next is the coalescing time. Coalescing time involves merging adjacent free holes to form a single larger hole, making it easier to allocate new processes. As each process reaches its time unit, it terminates here, as you will see. After that, there will be a 7-second interval for the compaction. Now you see, it's completed now. After all processes have been allocated and terminated, the final memory allocation and the time for compaction and coalescing will be displayed here. The final time unit will be 7.004. Let's take note of that. We'll be observing the difference if we change the time for compaction and time for coalescing whole later. Now, let's try to change it to 6000, and then let's try to put 2000 here. Now let's try to run the simulation. The final time unit now is at 8. The previous one was 7. The increased compaction time of 600 milliseconds means the memory will take longer to organize processes and create contiguous free space. This longer compaction time might delay the allocation of subsequent processes if the memory needs to be compacted frequently. To summarize, the best fit algorithm efficiently utilizes the memory by minimizing wasted space. Compaction and coalescing are crucial in managing memory fragmentation and ensuring efficient memory usage. Changing compaction and coalescing times can significantly impact the overall performance of the simulation. Thank you for watching this demonstration.